Hello everyone, in this video we are going to look at the problem B called stairs from today's Codeforces div to round 671. This first paragraph is of no use. Let's read the problem statement from here. Staircase is a squared figure that consists of square cells. Each staircase consists of an arbitrary number of stairs. If a staircase has n stairs, then it is made up of n columns. The first column is 1 cell high, the second is 2 cell high, and the nth column is n cell high. Okay, and a staircase is with n stairs is called nice if it may be covered by n disjoint squares made of cells. All squares should fully consist of cells of a staircase. And at the end we need to find out the maximum number of different nice staircases that can be built using no more than x cells. So if you see, this diagram represents a nice staircase who's having a height of 7, that is a staircase of height 7. Let's see what they are talking about. When they say it may be covered by n disjoint sets, what they mean is, suppose we are having one staircase. So we need to build this staircase using squares and a particular size of square. Suppose that is 1 by 1, that is this one is 2 by 2. We will have different colorings to each of these squares. Suppose red, white, and 3 by 3 will use some other color, and so on. We'll try to form this staircase using these squares, and after building up the square, we should make sure that we are not having any same colored square at the adjacent places. That is, they must not contain an adjacent cell. So if you see, if we start building a staircase from n equal to 1, so this is a nice staircase, as it does not collide, or it does not combine with any other staircase of similar size. And if we move to n is equal to 2, the staircase will look something like this. The only way we can build the staircase by using 3 squares of size 1 by 1. So if you see, they would be having this common side, and this is not allowed. So this is not nice. This is a nice one. And if we try to build a staircase of size 3, then it will look something like this. And we can build it using a square of 2 by 2 and 2 square of 1 by 1. You see, the same colored squares are not having any common edge. So 3 is also a nice staircase. And if we move to a staircase of size 4, then if we try to construct it using squares, first of all we should try to make the largest square possible. If we put the bottom right corner at this point, and this is the only way we can have a 2 by 2. Then if we try to fill up this place, then we can only fill up by using 3 1 by 1 squares, and this does not satisfy our property, as they are squares of same color or same size are having common side. So this is not a nice square. If we try to keep on building these squares, and see, there's a pattern here. See, the nice squares would be for n equal to 1, 3, 7, 15, and if we add 31. If you see, there is a pattern here, as the difference between these two squares sizes are 2, this is 4, this is 8, and this is 16, to 1. So you can see 2 to the power I. To build a staircase of size 1, we require only one, not size 1, let's say to build a staircase of size n, we require n into n plus 1 divided by 2 cells. This is just addition of or summation of first n natural numbers, as the first column contains one cell, then 2, then 3, and the last column would be containing n cells. Okay, if you see this pattern, this is logical as well. If you see, suppose we are having this staircase, as I mentioned that we should try to build as largest as possible, not build, place as large as possible square which is having bottom right corner at this place. So if we do this, suppose this is the largest square we can have, we are sure that at this point this is not like this is satisfying a property. So now we need to cover these two parts. To cover these two parts, they must also maintain the property what they are calling as nice staircase. In a way, this staircase should also be a nice staircase, and this must be a nice staircase. So it can only be possible, suppose if we are talking about a staircase of size 7, then this would be a 4 by 4, and this would be a staircase of size 3, and this would be a staircase of size 3. And we have seen then for n equal to 3, that is also a nice staircase, so it will satisfy. Similarly, for a staircase of n equal to 15, how we would be building it is, so we would be in the middle, we would be having a staircase of size 8 by 8, and here this is a not staircase, this is a square, and this is a nice staircase of size n equal to 7, and this is a nice staircase of size n equal to 7. As this is nice, and this square does not like this square is satisfying our property, so n is equal to 15 would also be a nice square. Cool. Okay, yeah, the way I said cool wasn't really cool. Okay, so what I did was I maintained a vector of pairs, pair of long, because the value can be pretty large. You see, in the first, this is a pair, suppose p1 p2. So p1 I'm maintaining the size of my staircase, and the second part I'm maintaining the number of cells needed to build that staircase, which is also equal to size into size plus 1 divided by 2. So I'm and I've called it nice, as I'm pushing all the nice staircases into it. So I'm just pushing all the nice staircase, make value equal to n equal to 1, then 3, 7, 15, 31, and I kept on doing it till I found that n is less than equal to 10 to the power 9. Why I stopped at this place? Because if I'm having n equal to 10 to the power 9, then the number of cells I need to build the staircase of this length would be 10 to the power 9 into 10 to the power 9 plus 1 divided by 2, and the maximum number of cells we can have is 10 to the power 18 itself. So we are sure that we won't be coming at this place at this value. So we have been given number of cells, and we need to construct or build as many nice staircases as we can. So what we'll be doing, we'll start from the smaller size and we'll go to the bigger sizes, like from 1, then 3, then 7. We will keep on adding the sizes. We'll keep, suppose this is n, this is size, and this is number of cells needed. Initially we'll maintain a count equal to 0, and we'll keep on traversing this our vector, which is called nice, and we'll keep on adding the cells needed. Suppose that is c1, c2, c3. We'll keep on adding it, and if we see that count plus ci is still less than equal to x, that is the number of maximum cells we can use, then we include this nice staircase and we move ahead. We update our count do count plus ci, keep on doing it, and if the point when we see count plus ci is greater than x, we just break out of the loop, as we cannot build any more, or we cannot have any more nice staircases. Pretty sad. Let's see the code now. Yeah, this is the vector which I was talking about. Yeah, this is that's the way where I push the values into my nice vector. It is the size which I talked about, and this is the number of cells needed to build the staircase of size n, and this is the gap which is increasing by the power of 2, as I had mentioned it in the beginning. Yeah, so gap is initially 1, then it became 2, then 4, 8, 16, 32, and so on, and we need to go to the power 10 to the 9, so it will at most it will take around 30 to 32 values only, as we are increasing the gap by this much amount every time. So now I have constructed my nice array. Then yeah, this is a pre-calculation. I'm not doing it for all the test cases. Then for the test cases, I'm maintaining the answer, which is the number of nice staircase I can build. Sum represents the number of cells which I've used till this point. Now I traverse my nice array. I see if the sum plus number of cells needed to construct a staircase of this size, that is nice I into first of pair into. If it is greater than x, I just break out of the loop. Otherwise, I increase my answer by 1, as I can build or have this staircase, and I update my sum, which is the number of cells I've used till this point, and at the end I'm just printing the answer. Okay, that's all for this video. I hope you learned something from it. I kind of liked it. If you also did, then consider subscribing to our channel. Yeah, that red button down there. I'll see you in the next video. Till then, adios amigos.